Here I'm going to go through the answers to our Term 1 formative test for 3.13 probability concepts. Let's have a look at question 1. So context, looks like haircuts, cut and colour and normal cut. We've got a nice two-way table, 500 customers. So determine the number of customers that came in for a cut and colour. So cut and colour is this portion here of our two-way table. So the probability of cut and colour equals 0.03 plus 0.21, 0.24, and then we want the number of customers. So it's going to be 0.24 multiplied by our 500 customers. So the number of customers with cut and colour equals 0.24 times 500, which is 120 customers. Okay, now we're asked to compare the conditional probability of being male and having cut and colour to that being female and having cut and colour. So I need to work out the probability of cut and colour given that we're male, and the probability of cut and colour given that the customer's female, and compare those two probabilities. So the probability of cut and colour given that we're male, well, that's going to be the probability of cut and colour and male divided by the probability of male. So looking up here, the probability of cut and colour and male is 0.03, and the probability of male is these two pieces here together, so 0.03 plus 0.28, which is 0.03 divided by 0.31, which if I grab my calculator, 0.03 divided by 0.31 equals 0.097. And then for female, similarly, it's the probability of cut and colour and female divided by the probability of female, which, looking up here again, we've got cut and colour and female is 0.21, and the probability of female, these two pieces together, 0.69. Okay, so 0.21 divided by 0.69 is 0.3043. So we want to compare these two probabilities, the probability of being having cut and colour given that you're male with the probability of having cut and colour given that you're female. So I'm going to compare those, the probability of cut and colour given female divided by the probability of cut and colour given male. So that'll give me the relative rates of those two to each other. So that's 0.3043 over 0.097, which is divided by 0.097, about 3.14, i.e. You're 3.14 times more likely to have a cut and colour if you're female. To have cut and colour if female rather than male. Okay, going on to B part. Or part B. So 1500 hairdressers, occupational hand dermatitis. I'm going to relabel that OHD just to make it more easy to follow. Compare the risk of getting occupational hand dermatitis for a male to the risk for a female. So the probability of occupational hand dermatitis given that you're male is the probability of occupational hand dermatitis and male divided by the probability of male, and that's just our conditional probability formula, which is 151 over 252. Because these numbers are all out of 1500, it's really 151 out of 1500 over 252 out of 1500. I can just ignore those 1500s, and it's 151 divided by 252, which is 0.5992. And the probability of occupational hand dermatitis given female, well, that's the probability of occupational hand dermatitis and female over the probability of female. Again, we could ignore those 1500, so it's 854 over 1248, which is 854 divided by 1248, 0.6843. Now we want to compare those. I'm going to take the bigger divided by the smaller, the same as I did back here. I took the bigger divided by the smaller, and that gave me that the larger one was so many more times more likely. Okay, I just find it easier to express it that way. So the relative risk, the probability of occupational hand dermatitis for females divided by the probability of occupational hand dermatitis given that you're male, is 0.6843 divided by 0.5992, which is 0.6843 divided by 0.5992, 1.14, i.e. females are 14% more likely to get OHD than males. Okay, now the final part, part C. 20% drop out before they graduate, 32% develop OHD. The risk of a student dropping out if they get occupational dermatitis is 10 times greater than if they do not get it. Okay, and we can assume these depends independent, so that's going to be important later on. Calculate the proportion of students that drop out that have developed. Okay, so I'm going to look at a tree for this, and I'm going to have occupational hand dermatitis and not occupational hand dermatitis, and then I'm going to have dropping out. So drop out, do not, drop out, do not. So what do we know? 32% of students develop occupational hand dermatitis, so I know that that's 32%. I'll make that 0.32. Because these branches have to add up to 1, that's obviously 0.68. Now, the risk of a student dropping out if they get occupational hand dermatitis is 10 times greater. So that's 10x, and that's x. Now what else do we know? We know that 20% drop out. So this here, 10x times 0.32, plus this here, x times 0.68, those two together equals 0.2. So let's see, does that give me enough to go back to find x? I hope so. Let's try this. So from here I've got 10x by 0.32 plus x by 0.68 equals 3.2x plus 0.68x equals 3.88x. So 3.88x equals 0.2. So x equals 0.2 over 3.88, which is 0.2 divided by 3.88, 0.0515. So if I go back and put that in for here, that's 0.0515, and this will be 0.515. So let's just do a quick check. 0.32 times 0.515 is 0.1648, and 0.68 times 0.0515 is 0.03502. If I add those two together, 648, oops, can't see my calculator there, sorry, plus 0.03502, that equals close enough to my 2, so that's just a rounding thing. But if that's 0.515, this must be 1 minus that, so it must be 0.485, and this must be 0.9485. Now calculate the proportion of students that drop out that have developed occupational hand dermatitis. So the ones that drop out are these two here, and occupational hand dermatitis equals 0.1648, and the probability of dropping out and not having occupational hand dermatitis equals 0.03502. So the proportion, proportion who drop out and have occupational hand dermatitis, so the proportion that drop out that have, okay, and equals 0.1648 over 0.03502, oops, plus 0.1648 obviously. So we're saying out of all the ones that drop out, what proportion of them have the occupational hand dermatitis? So that's 0.1648 over, we know that 0.2 is the dropout, so 0.1648 divided by 0.2, 0.824, i.e. 82.4% of dropout students, dropping out students have occupational hand dermatitis. Okay, so there's my answers for the first question. We'll pause there and I'll find some answers, schedule, and see how we've gone.